Great, so hello and welcome to this Oriel event for Oxford Meeting Minds Global. My name is Catherine and I'm the Alumni Relations and Events Officer here at Oriel. I'm very pleased to welcome both Oriel NCs and other alumni to this talk by Professor Nick Eyre. Just a few housekeeping points. We have muted you all for the duration of the talk. Should you have any questions, please just use the chat box and we will come to them at the end of the talk. So we are recording this talk and we'll be sharing it on our YouTube channel at a later date. So without further ado, I'd like to welcome our speaker, Professor Nick Eyre. Nick is Director of the UK RI-funded Centre for Research into Energy Demand Solutions. He is Professor of Energy and Climate Policy in the Environmental Change Institute of the University of Oxford, a co-director of the Oxford Martin Programme on Integrating Renewable Energy, and a Supernumerary Fellow of Oriel. From 2007 to 2017, he was a co-director of the UK Energy Research Centre, and before that, Director of Strategy at the Energy Saving Trust. Since October 2020, he has been Scientific Advisor on Climate Change to Oxford City Council. So Nick, over to you.
Thank you very much, Catherine, and hello everybody. I'm going to try to share my screen now, so let's hope that works. Right. Can people see that? Catherine, can you see it?
Yes, I can, Nick.
Thank you. Well, hello everybody, and welcome to this talk on energy without carbon. I really would prefer to be giving this in the Harris Lecture Theatre and able to see you all, but this is the second best, and it's really nice to welcome you here. I'm going to talk, I aim to talk for about 30 to 35 minutes, so there should be plenty of time for questions at the end. And as Catherine said, yeah, please feel free to put them in the chat. I won't look at them as I talk, but I will pick them up afterwards. I'm guessing you're a mixed audience, so those of you who know stuff about energy and climate change, apologies that some of this may be, you may think that some of this is a bit simplistic, but I need to start from the beginning, I think. So I've called the talk Energy Without Carbon because I think essentially that's the challenge. Ever since the Industrial Revolution, we've had energy systems have underpinned a modern way of life. And we now need to do that essentially without carbon emissions. So that's a grand challenge for society in the first half of this century. So what I want to talk about is I'm going to talk very briefly about carbon dioxide and climate science, and then get down to the business of how do we get a zero carbon energy system, and what does that mean for us? What does that mean for us here in the UK? What does it mean locally, and even what I'll end with a few thoughts about what it might mean individually. So carbon dioxide and climate science. Let me say at the outset, I am not a climate scientist, so this is pretty simplistic, but I actually do think that the relevant climate science is quite simple, is understandable by those of us who are not climate scientists. And it is important to communicate to people what it is. So this is a famous graph taken from the Mauna Loa Observatory, which is on the top of a volcano in Hawaii, to be remote from sources of carbon dioxide. And it shows what's happened to carbon dioxide concentrations in the atmosphere since 1958. So the late 50s, which was when I was born. CO2 concentrations in the atmosphere were just above 310 parts per million. They're now above 410 parts per million. So they've gone up by 30% in my lifetime. They've gone up by 50% since the pre-industrial level, which is generally taken to be 280 parts per million. So humanity has changed the atmosphere and is changing the atmosphere. Just anybody wonders why it's a wiggly line, it's because each year photosynthesis in the northern hemisphere takes out a bit of carbon dioxide in the summer, and then respiration of plants puts it back into the atmosphere during the winter. So you get that characteristic signal, but the overall trend is very clearly upwards. And that is raising global temperatures. The science is pretty clear that it is causal now, and the shape of the curve is indicative of that. So global temperatures, average global surface temperature, this is now about 1.1, 1.2 degrees above the pre-industrial level. And bear in mind that, and I'll say a bit more about this later, the Paris Agreement commits the countries of the world to restricting that to well below 2 degrees and aiming to restrict to 1.5 degrees. And if you project that line on upwards, you can see it's not very far to reaching 1.5 to 2 degrees. So why is climate change a problem? Obviously, there's a huge amount of work being done now on the impacts of climate change on various systems. This is a summary diagram taken from the last report of the Intergovernmental Panel on Climate Change, which is the big scientific assessment exercise that's undertaken every 6 or 7 years. And you can see that when the IPCC report was done, they put today temperature rise was around 0.8, and as I said, it's now nearer 1.1 or 1.2. And the bars across the further left show you what the impacts are in a qualitative way on different aspects of our planet. So unique and threatened systems are the first to be impacted. We're already seeing that on coral reefs and in the Arctic and the Antarctic. We're already seeing increased frequency of extreme weather events, droughts, hurricanes, floods, and that is projected to get worse as we go past 1.5 degrees to 2 degrees. The distribution of impact essentially is a measure of the extent to which it is poor people in poor countries who are bearing most of the impacts of climate change. And this is one of the extraordinarily unfair aspects of climate change, that those of us who are responsible for the emissions are in general not facing the biggest impacts. Other people are facing those impacts. And then as we move on to warming of 3-4 degrees, there becomes serious risk of the global aggregate impacts being very large, effects on food and water systems driving that, and large scale singular events like parts of Antarctica falling off, destabilization of the tundra and methane emissions from that, and those sorts of things. The IPCC last assessment indicated that if we didn't do anything, if we had no additional mitigation, well, the temperatures would rise by 3.7 to 4.8 degrees over the 21st century. I think that this diagram shows you why that is just not something we should contemplate, why we do need additional mitigation effort as quickly as we can. So that's my sort of potted summary of climate science. What's this got to do with energy? Well, the short answer is that most of it's to do with energy, because most of the emissions of greenhouse gases are derived from burning fossil fuels. So this is another figure taken straight from the Intergovernmental Panel on Climate Change report, showing where emissions have come from in the period 1970 up to 2010. And you can see the big yellow block at the bottom is basically emissions from burning fossil fuels and making carbon dioxide in that way. Smaller emissions of CO2, but still significant, of carbon dioxide from changes in land use, principally deforestation. And then emissions of other greenhouse gases, of which the most important is methane, CH4. So a range of sources of greenhouse gases we need to address, but the most significant is carbon dioxide. and the most significant source of that is from the energy system. And the reason for that is that the energy system is hugely dependent on fossil fuels. So this is a graph taken from the International Energy Agency, which tracks energy use across the world. And you can see how energy use has varied, in this case from 1990 up to the present day. It's quite a depressing graph in many ways. Energy use just tracks on up with a tiny blip there for the recession. We'll see a slightly bigger blip when we have the 2020 data due to the pandemic. But you see that energy use is dominated by oil, coal and natural gas. Oil, the red colour there at the bottom, coal and natural gas, the two blues at the top. Between them, they contribute most of the energy supply of the world. There's an orange chunk there, biofuels, which you might think is a step forward. Just bear in mind that most of that biofuels is waste wood collected largely by women in poor poor communities in poor countries. It's not really sustainable. Most of it is not modern biofuels being used in an advanced way. You can see the contributions that nuclear and hydro make there, but smaller contributions in the middle. And if you've got very good eyesight, you can see above the biofuels block, there's a small yellow segment. That is wind and solar, new renewables. So I'm going to be talking and being quite positive about new renewables in the next few minutes, but just bear in mind we are starting from a very low base and they don't make much of a contribution to the global energy system at the moment. What do we need to do in order to mitigate climate change? Well, this graph is taken from an academic paper to answer the question, what do we need to do? What needs to happen to global carbon emissions if we're to meet the goals of the Paris Agreement? Paris Agreement, remind you, signed by every country in the world, commits us to constraining global warming well below 2 degrees and to pursue efforts to limit the increase to 1.5 degrees. You may think that's not very precise wording, and you'd be right, but it's what the negotiators managed to negotiate. It also commits us to net zero emissions in the second half of the 21st century. And you can see that on the graph what that implies. 1.5 degree, meeting 1.5 degrees, the sort of blue bar, obviously there's an uncertainty and the diagram reflects that. If we aim at 2 degrees, then the green bar is more relevant. But in either case, the message is pretty clear. Instead of emissions going up, they need to start going down, and they need to start going down pretty quickly and very fast. So it's a huge change from what we've been doing in past decades. The implication, as I say, there is clear. We need a transition in the energy system, and we need to start now. Now, why is that so difficult? Well, it's because energy is important. Affordable, reliable, modern energy services are a basic human need. In our relatively high income societies, almost all our infrastructure and public services, our economy, critically dependent on reliable energy supplies, and the rest of the world aspires to that as well. It is still sadly true that 750 million people have no access to electricity, and far more than that don't have access to clean fuels for cooking. In those countries, and they're principally in sub-Saharan Africa and South Asia, that is the political priority for energy, is to get people access to what we take for granted. And so we can't just say the solution is to stop digging up fossil fuels, because we need something to substitute for those fossil fuels. So we need a systemic change in the way that we produce and use energy. And that's what people mean when they talk about the low carbon transition or the zero carbon energy transition. So this all sounds very difficult, and I'm not going to pretend it's easy, but how do we get to a zero carbon energy system is the next question. And there's a great deal of work going on this, as you might imagine, and being academics and researchers, we disagree with each other quite a lot, but I think there gradually is a consensus emerging. This diagram, the actual data on it is taken from a paper put together by a big international group led by Arnulf Grubler at the International Institute for Applied Systems Analysis in Austria, but by people from all around the world. And the message is rather straightforward, actually. We need to do two things. We need to start to reduce energy demand instead of increase it, and we need to shift the supply of energy to renewable energy as quickly as we can. So the left-hand diagram there shows the projections for what we need to do from 2020 levels to 2050 levels in terms of energy demand. We need to reduce energy demand. We need to reduce it mostly in the rich countries of the world, the global north shown in blue there. But actually, it is also now possible to reduce it in the global south. Since the industrialization we've seen in countries like China, it's possible to reduce energy demand in some of those countries as well. The right-hand diagram shows you the projection of what is needed in terms of expanding the supply of renewable energy, particularly there, wind in pink and solar in yellow, and you can see the rate of increase in the second quarter of this century that's projected there is very large indeed. Indeed, it's quicker, much quicker than the rate at which coal, oil and gas expanded as we powered the Industrial Revolution in the last century and indeed the previous one. So challenging without a doubt. The good news is that the efficiency improvement that we need to reduce demand and the use of these key renewables to some extent help each other. Clearly, reducing demand helps us helps any renewables that we bring in to be a genuine substitute for fossil fuels rather than simply adding to it. But also, the key renewables largely produce electricity, and in general, we can use electricity more efficiently than other fuels, so that helps us with our efficiency goal. So these scenarios have been thought through quite carefully. Nobody pretends that they're easy to deliver, but there does seem a way forward that will get us to a sustainable energy system. If not within my lifetime, then not that long afterwards, I would hope. So just let me say a bit about the key renewables. Historically, hydroelectric power has been the most important right from the early days of electrification in the late 19th century. Biomass is potentially an important source, but raises a lot of questions about the impacts of energy crops on biodiversity and the big debate about food versus fuel that I'm not going to go into here, but clearly very important issues. It's why most people think that the principal renewables we will be relying on in future will be wind, where there's a very large untapped potential, different in different places in the world, and the UK has a singularly good wind resource, both onshore and offshore, and solar energy, which even a decade ago, I was telling students was unlikely ever to be cost effective in this country. I'm now happy to say I was wrong. We've seen huge, dramatic cost reductions recently, which does make solar cost effective. And just so you know, the photographs there, of course, they make it there to make the slide look nice. but actually they are both in Oxfordshire. It's a wind farm near Shrivenham. It's a solar farm near Charlbury, both with funding from the local community. And that's something I'll come back to, is the sense that energy is becoming more local as well. I talked about dramatic cost reductions of solar. This graph shows exactly what has been achieved in the costs of solar energy since 1976. This runs 1976 to 2018. It's a logarithmic scale. It's the only way you can get all the data on, is to make the y-axis logarithmic. The price of solar modules has gone down by a factor of 250 since 1976. So a typical 2 kilowatt home system that you will now see on roofs in this country and other countries would have cost, that the modules alone would have cost you $150,000 in 1976. There weren't only in houses, of course. Pretty much photovoltaic panels were pretty much on spaceships in those days. The cost now of the modules would be about $600. The whole system obviously costs you a deal more than that, but $600 for a system that will provide half your house's electricity. And the good news is we can do even better. Colleagues in the Department of Physics in Oxford invented a perovskite technology that's now being integrated into solar cells. Well, that will dramatically improve their efficiency, and we hope also therefore reduce their costs. So there's more progress to come here, and certainly in the sunnier countries in the world, solar energy is very clearly the way forward. So this is a rather complicated graph that I think I'll largely gloss over. It's just to show you that people do document these things very closely. This is taken from the International Renewable Energy Agency, IRENA, who measure the cost of every new renewable electricity project in the world. And you can see that the costs for solar photovoltaics, for offshore wind, onshore wind, are the ones that are coming down dramatically, reaching values below $0.1 per kilowatt hour. So that's the level at which they're competitive with traditional fossil fuel electricity. So wind and solar are now certainly the cheapest options broadly available for low carbon electricity. But increasingly in many countries, they are also the cheapest electricity generation option, full stop. They are, and I think that the day I realized the world had changed substantially in energy was when it became clear that the cheapest way to generate electricity in Saudi Arabia is not to burn oil, but to use solar. That seems to me to be a pretty substantial change that we should welcome. Let me just say a bit about energy efficiency. It's the subject in many ways closest to my heart, because as Catherine said, the research centre that I lead works on energy use and energy efficiency. And I'm just going to show you this one graph, which is based on some work by Jonathan Cullen and others at a university somewhere in East Anglia that I won't name. Despite that, it's a very good bit of work, I should say. And they looked at all the ways that we use energy in the world and how much we could theoretically improve the efficiency. And we can do that, of course, by having better conversion devices, more efficient boilers, more efficient lights, more efficient car engines, industrial processes, etc. And that, they reckon, could almost halve our energy use. But then on top of that, you can improve efficiency by reducing waste through insulation, by reducing other losses, by better control systems. And of course, smart technology's got a lot to offer here. And then if you want to think more broadly, you can think about more efficient systems of provision as a whole. So the best known example being that public transport is or mass transit technically, is a more efficient way of getting people around than individual motor vehicles. When you add up all these things, it's pretty clear we can improve efficiency by more than 80%, probably between 80% and 90% is the best estimate. So we can improve efficiency a lot, and it looks like renewables are going to be increasingly cheap. That's the good news. I'm not going to pretend that that makes a low carbon energy transition simple. We've got all sorts of new problems that are thrown up which keep energy researchers employed and busy. These are two of them. One is the challenge of variability. It won't have escaped your notice that I've been suggesting that solar and wind will be the dominant forms of energy provision as we move towards the middle of the century. They are both variable resources. Electricity systems need to be balanced in real time. If they're not balanced on a second by second basis, we get blackouts. And so we are going to need other sources of flexibility. That may be other sources of flexible generation. It may be storage. It may be flexible demand. And I'll come back to say a few words about storage in a minute, because that turns out to be a really important area. In general, we will expect electrification to be the route to decarbonize many uses of energy, certainly home heating, certainly cars, but there are other things that it will be difficult to decarbonize with electricity. Electric planes, yeah, maybe, but not long haul. Electric ships, electric lorries, these are difficult to envisage. Some industrial processes can't be electrified as well. So we're going to need new zero carbon vectors, and there's a great deal of interest and work beginning on hydrogen as a source of energy for those particularly heavy freight and industrial processes. So there's a massive research agenda out there, and I don't want to pretend that we've got answers to everything. We haven't. Do want to say a bit about energy storage, because the cost of energy storage, like solar, not as dramatic as solar, but like solar, is going down very quickly and has already gone down by a factor of 5 or 6 in a decade. And lithium-ion battery costs now look likely to fall to $100 per kilowatt hour. That's a target that my colleagues in material sciences who work in this technology are looking at, and that would make batteries a game-changing technology for diurnal storage. Yes, particularly storing solar energy in the day to use at night. We should be proud of that. It's probably not everybody in the audience will know, but the lithium-ion battery was invented in the Organic Chemistry Laboratory in Oxford. We didn't make a great deal of money out of it, I'm told, at the time, but it is going to be one of the important technologies for the world as we look to use variable renewable electricity sources. Lithium-ion batteries won't solve longer-term storage issues. They won't be cheap enough to do that. The key issue, particularly in cold countries like ours, is that we use a lot more energy in winter than we do in summer for heating, obviously. And storing energy across seasons remains a technical challenge. But it's one, again, that people have got some ideas about, and in particular hydrogen, again, looks like it might be a way forward there. So interest in hydrogen, not just as a vector, a way of getting fuel to people, but actually a way of storing energy as well, and be happy to discuss that in questions if people are interested in that. Okay, so that's the general picture, and I just really want to move on to those questions I raised at the beginning. So, what does it mean? What does it mean for us? I'm going to start with the UK. I suspect most of the people listening, like me, are from the UK, and so it's an issue that concerns us. And actually, some good news. Whilst those data for global CO2 emissions that I showed you go up on ever upwards, that isn't the case in the UK. This is a nice graph put together by the Carbon Brief organisation, showing using national data, well-established national data, showing carbon emissions between 1850 and the present day. And it's probably not widely recognised that carbon emissions, even before the pandemic, were at the level of about 1890. So yes, carbon emissions in this country are lower now than they were when Queen Victoria died, which is not fully recognised, I suspect, by most of the population, and a pretty dramatic effect. And you can see that in recent years, particularly as use of coal has declined, carbon emissions have gone down quite substantially. We expect them to drop about 10% in 2020 from 2019 when the final data come through due to the pandemic. What of course we don't know is whether the changes in working patterns and other things will go on past that, or whether it's a blip. Interesting to see that, and of course people are beginning to speculate about it. How have those emissions reductions been achieved? This graph is taken from a paper I published with a colleague actually about 2 weeks ago now, so you're getting up-to-date information. The reason we did it was actually that the two of us were involved in putting together a talk for our then boss to give at the seminar that Margaret Thatcher called for her cabinet in 1989, which was the first time the British cabinet had ever discussed climate change. And we were asked, how can you mitigate climate change? I'm not going to show you what we actually said would happen. This is our revisiting the problem to say what has happened. And the message is clear. Improvements in the efficiency with which we use energy have been the dominant contributor to reducing emissions to date, followed by renewable energy, followed by other changes in the electricity sector, largely the replacement of coal by gas, and then some other smaller contributions from the waste sector, from reforestation, and from using biofuels in transport. And those are the principal contributions to date. And I think improved end-use efficiency and renewable electricity, as I suggested earlier, I think those will go on being the principal way that we reduce emissions in this country and worldwide. But we are left with an energy system in which there's not so much coal anymore. So these two charts show you where our energy comes from in the UK and where it goes to. It's not a coincidence that the two purple blocks, oil and transport, are largely the same, because most of the oil that we use is used in transport, and most of our transport system currently uses oil. Gas provides the workhorse for power generation, still to a large extent, and also, of course, for heating, both in homes and industry. And so you can see that the dominant questions in future decarbonisation are around these questions of how we replace oil in transport and how we replace gas in heating. So we have a fair idea what needs to be done nationally now. These conclusions are mine, but they're loosely adapted from the very substantial bits of work that have been done by the Climate Change Committee, looking at how the UK can deliver on its net zero target. And the key actions are pretty clear. Convert electricity generation to low carbon sources, principally renewables. Use that electricity increasingly in electric vehicles and other sustainable transport modes. Obviously, the more people can walk and cycle as opposed to use any powered vehicle, that helps too. And then begin to eliminate fossil fuel use, mainly gas, in buildings and industry, again by improving efficiency and using electricity. But also changes in what and how we consume if we want to anything we can do to reduce the amount of cement we use, to reduce the amount of steel that we use, obviously will help in decarbonisation. And we think if we do all these things, we can probably halve energy demand by 2050 and supply the rest of our energy from renewables. I'm more optimistic about reducing energy demand than some other people, I have to admit that, but I hope that my research centre will be producing a big study in the coming weeks that will show us that we can reduce energy demand by roughly that amount. So that's the overall national message, and people tend to think about energy nationally, and national governments hold most of the levers to energy policy, so there's a logic in that. But if you think about what actually needs to be done, and you believe me that a large amount of it is due to, will be done with renewable electricity, which is produced in a much more distributed way than traditional power stations, and if you believe that a lot of it is to do with using energy more efficiently, which is obviously a localized issue, then I think it becomes clear that it's not just a problem for national government, it's a problem at a more local scale as well. And we're increasingly seeing that, with many local governments declaring climate emergencies and beginning to ask what we can do locally. Oxford City Council is one of those. As Catherine said, I was asked to be their advisor on climate change last year. I'm just beginning to get my head around what that means. I thought you'd be interested to see what's planned locally here in Oxford. This graph, for which thanks to Rose Dickinson, Oxford City Council, shows how Oxford's plans, the brown triangle there with the green line, compare with the national targets in terms of reduced rates of emissions. You can see that in Oxford, we propose to have a target of reaching net zero by 2040. So faster, earlier action and an earlier net zero target. That's not just wishful thinking. We think it's possible that for Oxford to reduce emissions faster than the UK in general, largely because the hard to decarbonise sectors are not that heavily represented in Oxford. We don't have any airports. We obviously don't have any ships, unless you count canal barges, I suppose. And we don't have steelworks or cement kilns or petrochemical plants. So some of the really hard areas are not there. And therefore it's logical to think Oxford will need to reach net zero before the UK as a whole. But actually, if we're going to do it by 2040, it will also mean Oxford acting as a leader. And Oxford City Council actually had a climate assembly of a group of citizens randomly selected in 2019. And that was the dominant message from people in Oxford, that actually, because of the sort of city Oxford is, we think it ought to be a leader. And so there is, I think, determination across the political spectrum in Oxford for this to happen. What will that involve? Well, our local priorities in a city need to be on reducing energy use in buildings and transport. That's where most of our emissions are coming from. And of course, shifting energy to energy from clean sources, though most of those clean sources will be outside the city. It's in the nature of a city that it pulls in its resources from the surrounding area. So by 2040, we think we'll need to renovate pretty much every building in the city to a much better standard. We'll need zero carbon heating in every building. We'll need to change every vehicle to electric or hydrogen, and people looking at low emission zones as a way to do that. We'll need to increase our solar generation and increase the use of public transport and cycling and walking. It's not the agenda is in many ways, I guess, fairly obvious, but doing it is important and not necessarily very easy. We think that's not going to be, the city council is not going to be able to do that on its own. That's very clear. It's going to need a partnership between local government, businesses, universities, civil society, and the city has formed a partnership to do that called Zero Carbon Oxford, which pulls in the key players, the local government, the hospitals, the university, Oxford Brookes University as well, but also the bus company, the car factory, all the key actors who are going to need to play a role if we're going to reach this target. As I said, the university is one of those players. Really pleased that the university is now about to launch its sustainability strategy. It's available on the web for those of you who want to see it, and it covers all those areas that are set out on the right hand side. So not just not just the obvious things like carbon emissions from buildings and food and travel, but actually what research we do and what curriculum is provided to Oxford students in the future. But critically, ambitious targets, net zero carbon and a biodiversity net gain by 2035. And yeah, that will take investment, and I'm pleased to say the university is actually proposing to make that investment available. So really good news for those of us who care about sustainability, that our university is proposing to be a leader in this field. I think that's entirely appropriate. Let me just end, because I'm always asked, what does it mean for us individually? And I can draw on a bit of work that's been done in the Centre for Research into Energy Demand Solutions that I'm director of by one of my colleagues in that, Diana Ivanova, is a researcher at the University of Leeds. And she has, with colleagues, been through pretty much the whole of the literature that asks the question, how can we reduce our individual carbon footprint? And you can see the results there. The numbers are the tons per carbon that you get by making these changes to lifestyle. So living car free, battery electric vehicles, flying less, renewable electricity. Again, pretty obvious, a lot of it, but really useful to have those numbers. I'd put a health warning on the exact numbers. They're based on an international literature review. They're clearly dependent on assumptions, and they won't be the same in every place and for every person. But it gives a sense of what people can do, right down there to vegan diets and heat pumps and improved cooking equipment and renewable-based heating. So, as you'd expect, not one thing, but lots. I think my final thought would be, let's not make this we all need to be miserable and go and do difficult things. Realistically, changes like that are going to depend on public policy, on the right infrastructure being available, on businesses providing services in the right way. You can't use public transport if there isn't a public transport system, would be a pretty obvious comment. But actually also changes in societal attitudes. And I think we are seeing those changes in societal attitudes now, particularly in the period immediately before the pandemic. We're seeing a lot of attention to these issues, and in particular, younger people recognizing that their future is at stake here, and that they need to stand up and get governments and businesses and other older people like me to take notice and to change. So I'm going to leave it there. I believe there will be questions in the chat. I'm going to stop my screen share so I can see some more of you and hopefully see the questions.
Great, thank you so much, Nick. That was a really interesting talk, and good to end on a positive note as well. I always find with these sort of things, it's nice to end positively. Yeah. So yeah, we've got lots of questions in the chat box. Let's fire away, I guess. So what do you think we should be saying in November for COP26?
So COP26, I guess most of you will know, but it's the 26th Conference of the Parties to the Framework Convention on Climate Change, and its critical role is going to be to think to get more agreement on how we deliver those targets in the Paris Agreement. The Paris Agreement is great. The targets in it are great. If we can, the problem is that we're not delivering them. That if you add up what the countries in the world have committed to, it doesn't meet the targets in COP26. So it's a tough one for our government, because our government will be is the host and will therefore be chairing it and trying to make these commitments happen. It's the pathway I've set out. I think we need to be getting those sorts of commitments from governments, and really building the recognition that the two areas are identified: using energy more efficiently and using renewable energy sources are not really a pain agenda anymore. If they ever were, they make a lot of sense, not only in cost terms, but in reducing other pollution and all sorts of other benefits as well. So I'm not going to pretend to know exactly what our diplomats who are leading this should do. That's what we have diplomats for, to work out what's possible and what steps forward can be made. It's a tough job they've got, for sure.
Great. So next, is there any way of achieving the target without accepting A, colder homes, and B, less travel?
So A, we don't need colder homes. I mean, if people are heating their homes to 24 or 25 centigrade, then sure, it makes sense to have colder homes, and people would be healthier. But for those people, and there still are too many in our country who live at 12, 13, 14, 15 centigrade, no, we don't need that. And if we insulate our homes properly and use efficient heating devices, we can have warmer homes and lower carbon emissions. That is part of what we've been doing for the last 20 or 30 years. We need to speed it up. We've not done so well over the last 10 years, but no, there's no need to have cold homes. No. Less travel depends who you are, right? If you're my mum and you live in a care home and you haven't been out of it for the last year, less travel is probably not what you need, and not really going to make much difference. If you are looking forward to jet setting around the world and doing 10 long haul flights a year, then actually, yeah, we probably do need you to do less travel, and it probably won't do you any harm. And the technology we've all got used to using in the last year can help us a great deal.
Great, thank you. So what's your view around hydrogen as an energy vector for clean mobility and industrial applications?
Yeah, I think, as I said, I think hydrogen is going to be important. Where you can use electricity directly, it makes sense to use electricity directly rather than convert it into hydrogen and use the hydrogen. That's just a more efficient and smarter way to do things. But as I said, it's going to be it's difficult to see that you can fly aeroplanes on electricity. You might be able to do short amounts, or large tankers, even heavy lorries. It's difficult to see how you use electricity to make steel or cement. We are going to need other ways of doing that. Hydrogen's the most obvious. Some colleagues in Oxford are looking at ammonia as a way of storing, essentially an alternative to hydrogen. It'd be easier to store. So there are some other options. It doesn't have to be hydrogen, but I suspect hydrogen is the front runner for these. And yeah, electricity first, but something else as well will be needed.
So someone's asked, what is the alternative for domestic gas boilers and how will replacements be funded?
If we knew how we're funded, that would be good. So that in most cases, I mean, there are a few options. Hydrogen is one, but hydrogen is going to be quite expensive. The main option is going to be the electric heat pump. So an electric heat pump uses electricity, but it uses it with a much higher efficiency than you get out of a gas boiler. So the running cost should be about the same. The capital cost is currently much higher. So it's a very good question how it will be funded. The government is in the process of producing a strategy on buildings and heating. it was in the process of doing that. It was about to come out 6 months ago. It was about to come out 3 months ago. It's still about to come out. I've given up holding my breath. I don't know what the delay is. I know it's been largely written by colleagues in Bayes who understand these issues. I suspect the issue is getting Treasury approval to answer the question, how is it going to be funded? I don't know that, but that's my best guess.
Great. So have you considered the use of batteries to smooth the demand over 24 hours, i.e. store energy produced overnight for use during the day? I think you kind of touched on that a little bit, didn't you?
Yeah, though interestingly, and that is the way we've generally thought about energy storage. I suspect in future we'll be talking about using energy produced during the day in the night. As if we get a significant amount of solar energy, then we will have excess production, certainly at midday, and our peak demand is in the evening. But yeah, I think batteries are going to be really important for smoothing demand over the 24-hour period. To some extent, that depends on, as the question implies, on whether your source is nuclear or hydro or solar or wind, because they all have different characteristic generation patterns.
Right. So starting with the UK, how do we make it socially unacceptable to remain indifferent to this debate, e.g. buying an SUV car for the look and feel rather than because you need to?
Well, if I knew the answer to that question, it would all be very easy, wouldn't it? You have to go and you have to ask, why do people get SUV cars? And sometimes they get them for perfectly good reasons of safety, or because they've got a lot to carry, or they've got many kids and they feel safer that way. Certainly in the street in which I live, which is a very narrow street in East Oxford, you get a pretty dirty look if you take an SUV down the street, because it gets in the way of the bikes, and most of us are cycling. So I think there is a cultural aspect to this as well, and I'm not going to suggest that the culture in East Oxford should be transported to the rest of the country, though it would probably help. But actually, cultural change and what is acceptable does change. You need to look at diets to understand that, for many people now, a vegan diet has become a viable and an attractive thing. We have to make this agenda an agenda about living better and not an agenda about living worse, right? So, years ago, certainly it would have been thought in many cities, including the one in which I was brought up, a bit odd if you cycled to work. Where I live, 2 miles from the university, it's a bit odd not to cycle to work, really. So, culture really matters, and I'm not a cultural theorist, so I'm not going to speculate further how to go about changing it. Other than to say, I think leadership's important. Actually having people in senior positions doing the right thing is quite important.
Great. So someone's asked, what about CCS? It has its own issues, but the techno is available now. Can it help in the energy transition?
Yeah, so CCS, carbon capture and storage, essentially means taking the carbon dioxide out of either waste streams or ultimately even the atmosphere and burying it underground. I think 10-15 years ago, it looked like that might be an attractive option for electricity generation. I think the falling costs of renewables mean that it won't be used in that way. I think it's certainly a candidate for using on some of these difficult to decarbonize processes like cement kilns and steelworks. I think it'll be largely be in competition with hydrogen there. So yeah, it can help, but my personal view is that it will be a rather marginal player in the overall picture.
Yes, someone's asked, is anyone in Oxford looking at the behavioural changes which may give results?
Well, I gave that final diagram, which shows you what, and that's not an it's not an advocacy piece. It's just a research piece that identifies lifestyle change, X leads to changing carbon emissions, Y. That doesn't tell you how to get those behavioural changes. And I think my colleagues who are more into the social science than I am would say some of it's behavioural, but actually a lot of it is social, because many of our individual behaviours are strongly identified by social norms, by the way we're brought up, by attitude, by broader cultural attitudes, which is why I talked more about culture than behaviour. We certainly aren't going to get an energy transition by persuading 7 billion people one at a time to change their behaviour. It has to be a bit clever and a bit more collective than that.
Great. So a very specific question about how and when will electric vehicles have the power and range to pull a caravan around Scotland?
I think it depends which bit of Scotland you're talking about, Nick. I think it probably do around parts of it. If it's the parts of Scotland that I know and love, then I think, yeah, you are pushed to find a charging point north of Fort William, I think. But I'm tempted to say you need to lobby Nicola Sturgeon on that one, I think.
Great. So a question about why nuclear energy generation is ruled out as a low carbon source.
Right. So I haven't ruled it out. That for transparency, I should say my doctorate is in nuclear physics. I worked for the Atomic Energy Authority for the first 12 years of my career, so I'm not a sort of classic anti-nuke person. Nuclear electricity at the moment is much more expensive than renewables, so it's the question's right. It's not as variable. All power sources are variable because all power stations go wrong, but it's not as variable. Its power density per unit area of generation is much greater. That's true, but actually solar and wind don't take a huge amount of land area. Biomass does. I think the bottom line is cost, and so I'm saying my guess is that even with the additional storage we need, that wind in this country and solar in some other countries will be cheaper than nuclear. Nuclear costs have not come down. If anything, they've gone up.
Great. So there's a few questions about sort of what your advice would be for, so someone's saying that they want to put solar panels on the roofs of their house, and the roofs in the street are all south facing, but the majority of people are against it. What's a good response, sort of, say, for people?
South facing, the majority of people are against it owing to the change in appearance of the roof. Well, again, it's the cultural change problem. You can probably see that if you on my picture that I'm in a loft room. And the reason I don't have solar panels is there isn't anywhere to put them, because that window you can see is facing northeast, so you wouldn't put them there, and there's no other roof facing in the opposite direction. So you've got different problems in different places. But if the problem is the people in the street don't like it, then we need to persuade the people in the street. Now, as I said, I don't know how to do that, but my sense is that it is moving. And I know there are people in Oxford who are being prevented from having solar panels on the roofs because of planning consent issues in conservation areas. So there's also people saying, I would like solar panels, or not being allowed them. This shows the diversity we've got in our society, which in general I think is a good thing. But I think the cultural change is going in the right direction on this one.
Great. So what are your views about cities that are aiming for net zero by 2030? Is that achievable or a fantasy?
A fantasy, in short. I mean, it would be nice, but what does net zero mean? It means getting rid of gas boilers. It means getting rid of internal combustion engine vehicles, not some of them, all of them, right? Are we going to do that by 2030? Well, I suppose you could conceive of a world whereby we told people that they had to, a gas boiler that had just been put in had to be scrapped, or a vehicle they bought last year they couldn't use. I don't see our politicians doing that, and I don't think I would do it either. I think 2040 gives the time for those capital stocks to turn over. It gives us time for the supply chains to build up, because, you know, actually not everybody could buy an electric vehicle tomorrow because the market isn't there. Not everybody could get an electric heat pump in tomorrow because the supply chain isn't there to deliver that. So these things are big changes, and they will take time. 2050, I think it's doable. 2040, Oxford's target, I think we're pushing it, to be honest. 2030, no, I don't think it's going to happen. And I don't think people should sign up to targets without a sense of how they're going to deliver them.
Great, so we've got time for a couple more questions, I guess. So one, going back to Oxford, do you know how individual colleges and faculty buildings are addressing the challenges?
So each college is, of course, independent, and we wouldn't wish to argue against that, would we? I think that the Conference of Colleges is working together, and the Conference of Colleges is represented on Zero Carbon Oxford, as I mentioned, as well as the university. The university addresses these issues largely through the Estates Department, which has got a dedicated sustainability team who've developed a sustainability strategy, and they're great. They're a great bunch of people, and they're doing some fantastic work on our buildings, but also on transport and food and procurement and a whole bunch of other issues. And they're the specialists. So yeah, some of my colleagues and then have had an input to the sustainability strategy, but it's the professionals in the Central University team who are responsible for it, and that's the way it should be. It should be a corporate a part of what our university does as part of its day-to-day work.
Great, so we have come to the end of our time today. I think we've covered pretty much most of the questions. Belinda has popped some stuff in the chat box about stuff we could, climate change toolkits and stuff, which people might be interested in looking at. But yeah, so thank you so much to Nick for that fascinating presentation and for taking time with all these questions. We really appreciate it. And thank you to everyone at home for joining us. I hope you all have a great evening and look forward to seeing you in person soon. Thank you very much. Good night.
Thank you, and thanks everybody for your questions.